Let us now create some simple models based on this information. These are requirements models. What must you expect from a requirements modeling technique? A requirements modeling technique must do two things. It must reduce the risk of misinterpretation, and it must make it easy to be able to incorporate changes to requirements later. To reduce the risk of misinterpretation, we can use some form of graphical notation. To make it easy to be able to incorporate changes later, we must minimize redundancy in the requirement specification, just as we minimize redundancy in a database design.
The first attempts at requirements modeling were focused on the process, the business process. The process model represents the logical extract or the essence of the business process using a diagram called the data flow diagram. You may have already guessed. This diagram focuses on the bottom left-hand corner of our 2x2 matrix.
You will now see a data flow diagram that represents a part of the essential processing in E&R. We have a process called compute grades. A process needs to process something, so the process has some data flowing into it. A process also needs to produce some useful output, so it has some data flowing out of it. The process reads from a data store called employee course information and produces a list of grades for each course. The term data store is in keeping with the convention that we must show only business essence. A data store indicates only a source of data in abstraction, without specifying whether it is a database table or a file or a sheet of paper.
Process modeling has a serious drawback. Business processes vary with time. The way grades are computed can change from trainee batch to trainee batch. This has an overhead of keeping the model in sync with reality. However, the fact that grades are assigned to trainees does not vary with time, or at least changes very infrequently. This motivated focus on data rather than on process. The reasoning was, if you got the data right, the process is only a step away. Business data is modeled using a diagram called the entity relationship diagram. This diagram focuses on the top left-hand corner of our 2x2 matrix.
You will now see an entity relationship diagram that represents a part of the logical or essential business data in E&R. It has boxes that represent the entities we discover in the business domain: course, employee, and nomination. It has lines that relate pairs of entities. These lines are called relationships. The line labeled takes tells us that employees take courses. What is the minimum number of courses that an employee must take? Is there a maximum? Such questions are answered by looking at two symbols at the course end of the line. The symbols here indicate that an employee takes at least one course and at most an indefinite number of courses. Similar questions about the number of employees that can take a course can be answered by looking at the employee end of the line. For instance, the symbols here indicate that a course can have at least 0 employees and at most an indefinite number.
As systems became more and more complex, it was realized that relying on just a data model or just a process model alone will not do. To specify requirements more comprehensively, it is important to model both the business data as well as the business process for a particular application. In addition, it is important to invest time and effort in modifying these models as and when businesses change. This was the next step in the evolution of modeling. However, it was realized that the coupling between process and data models must be kept to a minimum. What this means is that the person doing data modeling for a particular application need not know anything about the process model, and the person doing process modeling for the same application need not know anything about the data model.
That last statement sounds surprising. Should there not be some correspondence between the entities and the relationships on one hand and the data stores on the other? The answer is yes, there is a coupling between the two, but it is intentionally kept loose. For example, though the data model indicates employees, courses, and the relationship between the two, the process model merely has a data store called employee course information and does not bother to show more detail. The focus is and remains the process alone. Which comes first, the process model or the data model? Fortunately, this isn't a chicken and egg problem. The answer is any. The two models are practically independent or orthogonal, which means you can do either one first. So then, how does a requirements model help me, the analyst? A requirements model helps the analyst ask the right questions. To see what I mean, let's return to the data model. This model tells us that each employee takes one or more courses. Does this mean that each newly recruited analyst, manager, and vice president is forcibly made to take at least one course? Unlikely. What it's more likely to mean is that the E&R system is interested in keeping information only about those employees who have taken at least one course. The end products of requirements analysis, the data and process models, are statements of business essence. Who can review these models? Let's look at the consumers of the E&R system and see if they can review them. Usha and Damodar are the ultimate end users of the E&R system. Can they review my models? If they must first be taught data and process modeling. Good idea, but doesn't work in practice. Usha and Damodar are too busy in their day-to-day work to be able and willing to sit in a 6-hour class learning some abstract modeling notation. Besides, they may not know enough about E&R's business policies to be able to detect any subtle flaws in my model. Kochikar looks like a likely candidate to review my models. He is knowledgeable, knows the ins and outs of E&R business policies, and also knows a good deal about requirements analysis. Unfortunately, there are several modeling notations in vogue and several modeling schools of thought too. It's quite possible that Kochikar may not belong to the same school of thought as I do. This can give rise to communication problems which I, the analyst, must overcome.